All right, part one is asking us to find the impulse imparted to the tank. So our equation for impulse, J, is equal to change in momentum or force times time. In this case, we don't know the force, even though we do know the time. So we're going to go with the change in momentum. Now, for our momentum, momentum's mass times velocity. The mass of the tank is not changing. What is changing is its velocity, how fast it's going. So it tells us it's going from 3, and then it's brought to a halt. So our change in velocity is from 3 to 0. Or the change in velocity is just 3. So at this point, we can go ahead and plug in our numbers and find the impulse. So mass is 15,000 kilograms, and our change in velocity is just going to be 3. So if we multiply those together, my impulse, that is going to come out to be, 3 times 15 is 45,000. That's our answer for part 1. For part 2, the other equation we have for impulse is force times time. And this one's asking us for force. So we do know what the impulse is. That's what we saw for in part 1. And we know what the time is. For me, the time is going to be just 1 second. So to solve for force, if we move this around, F is equal to the impulse, this is our answer for part 1, divided by the time. My answer for part 1 is 45,000, and my time was only 1 second. So my answer for impulse is going to be 45,000 as well. And this is in newtons. All right, so what is more important in determining the amount of damage an object sustains in a collision? So if you throw an egg against a wall, or you throw an egg against a hanging bed sheet, those are going to have different results. Throwing it against the wall, it's going to have a certain amount of total momentum, and that momentum is going to go to 0. It's going to change to 0. But that's going to happen in a very short amount of time, and so it's going to experience a big force, and it's going to shatter and break. As opposed to throwing the egg against the bed sheet, it has more give to it. So even though it's the same total change in momentum, the time of impact is going to be bigger, and that means that the force is going to be smaller. So our impulse J is the same, but by making the time big, that means the force is small. Whereas throwing it against the wall, we had a tiny amount of time, but we had a big force. So